Welcome to the deep dive. Today, we're really getting into something vital for anyone working with data. How do you build systems that don't just fall over when something unexpected happens? We want systems that are genuinely resilient, you know?
Exactly. We're looking at how processing failures can actually become, well, points of intelligence rather than just dead ends.
And our guide for this, interestingly, comes from a theoretical concept, the Turing Machine. We're using that idea of its head moving right for success and left for some kind of retreat or failure.
Right.
And that left movement, that's what we're really going to unpack today. It seems simple, but it's where the real complexity and, frankly, the opportunity lies for modern ETL pipelines.
Our mission really is to see how moving left doesn't have to mean your whole process grinds to a halt. It can actually trigger smart error handling, data quarantine, maybe automated recovery, stuff that's absolutely essential when you've got lots of things happening at once, like in multi-threaded systems.
Okay, so this is like the advanced course in error handling compressed.
You could say that. It's about getting ahead of the failures.
Okay, let's unpack this. So this Turing machine idea, how does it map, practically speaking, to, say, processing a big CSV file?
Well, think of the infinite tape as that stream of data, maybe line by line from the CSV. Each line is like a cell on the tape.
And the CSV-based processor, that's the read-write head?
Precisely. It moves along the tape, reading each line, which is like a character in its alphabet, the CSV result object in this case.
Got it. So the right movement is the happy path. What does that look like in code terms?
Right means everything worked perfectly. Two key things. First, your application logic says the data is good, like CSV result.as valid, returns true. But crucially, the second part is that the attempt to save it to the database, using something like service.verify brains base entity, also succeeds. And not just succeeds, but the transaction is fully committed.
Ah, so it's an atomic right, all or nothing.
Exactly. Durable, reliable. The changes definitely saved, no half measures.
Okay, that's the right path. But the left movement, that's where it gets interesting and often painful. What triggers that?
Well, there are sort of two main flavors of left.
Okay.
The first is cleaner. The application validation itself fails. CSV result.as valid comes back false. Maybe the data is incomplete, wrong format, whatever.
So you log it, maybe flag it, and just move on to the next line. The head effectively skips and moves right to the next piece of data.
Pretty much. It's a rejection, but a controlled one. The real headache is the second type of left movement.
Which is?
Persistence failure. The data looked perfectly fine according to your rules as if valid was true, but when you actually tried to save it to the database, nope, it failed.
Right, and that could be anything. A network hiccup, a database deadlock, maybe hitting a unique key constraint you didn't expect, or some other random exception.
Exactly. Transient stuff, persistent stuff. And this is where the approach in the source material, the on failure leading to system.exit theorem, this point.
A hard stop, pulling the plug.
Yeah. It's terrible for any real system. Imagine stopping an entire assembly line because one part is slightly off, you get data loss, zero fault tolerance, you're basically flying blind.
So what's the vision? How do we make that left turn smarter?
Okay, so instead of halting, we need mechanisms. First up, dead letter queues or DLQs.
Right, the DLQ, like a holding area for failed items.
Sort of, but it's more than just holding.
Think
of it as a dedicated space.
Yeah.
Maybe a specific Kafka topic, a RabbitMQ queue, even just a database table for items that passed validation but failed persistence. It quarantines them, allows you, or maybe an automated process, to inspect what went wrong, maybe fix the data or the underlying issue, and then crucially reprocess it. You don't just lose that record.
Okay, so DLQs handle the persistent failures or things needing manual review. What about those temporary glitches the network drops?
That's where automated retries come in. You use libraries, like Spring Retries, a common one, that can automatically try the database right again if it fails with a potentially transient error, usually with some kind of backup strategy like waiting a bit longer each time. If it still fails after a few tries, then it goes to the DLQ. It lets the system heal itself from temporary hiccups.
Makes sense. Self-healing for transient issues, quarantine for persistent ones.
And underpinning all this, you absolutely need solid monitoring and alerting. Every time something triggers a left move, especially ending up in a DLQ, you need visibility. Tools like Prometheus, Grafana for dashboards.
And alerts going to PagerDuty or Slack so someone knows immediately.
Definitely. Plus, really good auditing. You need logs tracking exactly which record failed, why, the error, the stack trace, when, for debugging, for compliance, everything.
Now, a lot of these systems aren't just processing one thing at a time. They're multi-threaded, right? Lots of heads moving on the tape at once. How does this left movement work there without causing chaos?
That's a really critical point. If you have, say, a thread pool task executor running multiple processors in parallel, like multiple Turing machine heads, a left movement for one specific data item, one thread, must not block or stop the others.
Ah, so one thread hitting a persistence error and retrying or sending to a DLQ doesn't halt the threads processing perfectly valid data next to it.
Exactly. The architecture has to ensure that independence, the DLQ and retry mechanisms isolate the failure to that specific item's processing path, allowing the rest of the pipeline to continue flowing smoothly. It maintains throughput for the good data.
So what does this all mean? What's the big picture takeaway here?
The takeaway is pretty fundamental, I think. You have to stop thinking of failures, these left movements, as just errors to be stopped by. By intelligently embracing them using DLQs, smart automated retries, comprehensive monitoring and alerting you, transform potentially fragile ETL processes into genuinely resilient, enterprise-ready systems, ones that can actually cope with the messiness of real-world data. It's not nice to have. It's a baseline requirement now.
That really reframes failure. So a final thought for everyone listening. If this left movement in data processing can be a path to deeper understanding, resilience, and recovery, what other parent failures or setbacks, maybe in our work or even our lives, could we reframe? Could they also be intelligent opportunities for growth and building resilience? Something to chew on. Thanks for tuning in to The Deep Dive.